So today we're going to talk about linear functions. And by the end of the day, we want to be able to say, I can classify equations as linear functions. We're going to learn a little bit more about what it means to be a linear function. But first, what two words do we see within linear functions that maybe we could get a definition of what a linear function is? Well, we know that linear means line, and a function is any relationship where one input has just one output. And we talk about linear functions, and we say it's a function whose graph forms a line that is not vertical. Okay, we see linear within linear function, so this must be a linear function if it forms a line. And so we look at these two examples. To our left, we have this guy right here, and we say, hey, is he a linear function? Yes or no? Yes, he is, because he's a straight line. And we look at this guy here, is he a linear function? Well, the rule said a linear function is any function whose graph is a straight line that is not vertical. And this guy, he's not vertical, he's horizontal, so he must be a linear function. Absolutely. So we look at these two guys and we say that both of these graphs are linear functions, therefore they must be linear equations. And their domain and range below, right here to the left, is the set of all real numbers. The next question is, what is the domain of this function below, the red line? What is the range? Well, we know that the domain is our x values, or our inputs, and we see because of our arrows here and here that this graph goes on to the left and to the right for indefinite time. So we know our domain is all real numbers. We can plug in anything that we want. However, we'll see because the line is on y equals -2, we're always going to get an output of -2. Therefore, our range, or our y values, our outputs, is always going to be -2. So we talk about a linear function can be written as a linear equation, and those linear equations have a standard form, and that form is, if it's linear, it will be represented by a linear equation, and that form is, the standard form of a linear equation, ax plus by equals c. Yes, you should write this down. It's very important that you realize a, b, and c have to be real numbers, and a and b cannot both be 0. One of them can be 0, either a or b, but they cannot both be 0. And notice that it doesn't say anything about c. C can be 0. There's nothing wrong with that. Okay, c can definitely be 0. And here's another example. 3x minus 2y equals 6. What's the value of a? What's the value of b? And what would be the value of c in this equation? 3x minus 2y equals 6. And we'll see that a equals 3, b equals -2, and c equals 6. This is definitely a linear equation. Another example, 8x equals 16. Wait a second, we don't have a y. Is this a linear equation? Well, we'll look. A equals 8, b equals 0, and c equals 16. This is a linear equation, definitely. But we're going to study a little while, see if this is actually a linear function. Important notes on linear equations. 1, both x and y have to have exponents of 1. 2, x and y are not multiplied together. And 3, x and y do not appear in denominators, exponents, or radicands. It's very important that these 3 rules hold true. X and y have to have exponents of 1. They are not multiplied together, and they do not end up in denominators, in exponents, or in radicands. And so we look at our rules, and we know what's going to make a linear equation. Now, let's look at these two examples and ask ourselves, are these linear? Is this guy right here linear? Does he follow the rules? Are x and y multiplied together? Do they have exponents of 1? Do they find themselves in exponents or radicands or denominators? And then we'll look at the guy to the right, or the guy in red here, and we'll ask ourselves the same question. And my question to you is, are they linear? Let's take a look. Well, we'll see that y minus 3 equals 2x forms a nice straight line, so it is a linear equation. And we'll see that y equals 2 divided by x doesn't fit my rule. X is in the denominator, and we'll see its graph is actually a hyperbola, something that we'll discuss in the future. So we're able to clearly figure out what is a linear equation. Looking above, we have ourselves a horizontal line. Is it linear? Yeah, of course it's linear. It follows the pattern. It's a linear equation. It forms a line. Is it a linear function, though? Well, think about what we said about linear functions. And we have our horizontal line, y equals 5. No matter what I input into this function, my x values, my domain, which can be all real numbers based on a horizontal line that extends left and right indefinitely, we're always going to get an output of 5. And when we look at its standard form, we'll say that a equals 0, b equals 1, and c equals 5. We've got ourselves standard form of a linear equation. And is this a function, and why? Yes, it is a function. Each input has just one output, and that makes it a function. Let's take a look at horizontal lines. Horizontal lines are functions, and yes, you should be writing this down. For each input, there is just one output. That makes it a function. That's the best definition of a function you can get. For each input, there is just one output. Y equals -2. This is a horizontal line. It's another example. Even though at every input or x value we input, we get the same output, -2, each input has just a single output. And that makes it a linear function. Horizontal lines never have an x in the equation. If it's going to go straight across horizontally, there will be no x in the equation. We'll only read y equals c. Y equals some constant. So what is the value of a in horizontal lines? Remember, ax plus by equals c. What would be the coefficient in front of the x that would get rid of it? Yes, a is always equal to 0 in horizontal lines. Take a look at this green line. What can you tell me about it? Well, I can tell you its equation is x equals -4. It is a linear equation because it forms a line. It fits the standard form. A would equal 1, b would equal 0, and c, of course, is equal to -4. It goes straight up and down at x equals -4. But is this a function? Why? No, it is not a function. Why is it not a function? Well, we'll clearly see that at -4, when I plug in -4 for x, I can get out more than one output. If I plug in -4, I may get out 3. But if I plug in -4, I may get out 0. When I plug in -4, I may get out -5. There are more than one output for this input, and that means that it is not a function. So vertical lines. Vertical lines are never functions. Never, ever, ever. Yes, you should write it down. Vertical lines are never functions. If it's straight up and down, it is not a function. Why? For each input, there are infinite outputs. That's what makes it not a function. If I get out more than one output, it is not a function. X equals 9. This is an example. This equation has only one input, 9. However, that input has infinite outputs. As we showed in the example before, when I plug it in this case, if I plug in 9, my y value could be 8, my y value could be 10, my y value could be negative 50. I have more than one output. So let's summarize. Talking about linear equations and linear functions. Linear functions. In the standard form, ax plus by equals c, where x and y have to have exponents of 1. They're not in denominators, radicands, or exponents, and they are not multiplied together. Graphs are lines. The graphs of linear functions are straight lines. Diagonal lines, ax plus by equals c. That'll form a nice diagonal line. Horizontal lines, simply y equals c. Horizontal lines are functions. And then we have vertical lines. Vertical lines are not functions, but they are linear equations. We can write a line based upon this equation. X would equal c. So now it's your turn. Please get into your groups, work on pages 155 to 160, and your homework will be 161 to 162. I only want you to do questions 7 through 14, 16, 17, and 18. I will be in class tomorrow, and we will work more on this. Have a great rest of the day.